Assalamu alaikum. So lesson today is about relation and function. But before we define what is relation and functions, we are going to talk about the main concept. Point in a coordinate plane. Example, if coordinate plane and I have a point define the location of that point. So I need to use this coordinate. So we'll get 5 and project a point vertically on the x-axis. Location of the point in fact is -8. So it's exactly another pair. You see the other pair is in fact the address of that in the coordinate plane. So let's write this is a way to present of a point in a plane or has coordinates a, b. So a is the coordinate a is, and the b is y coordinate. Now let's define what is relation. So simple as it is. Relation is of order pairs. So in fact x, y are number or expression, either way. For example of example R1 is a set of 2, 5, 1, 0, or I can use a 0. So those are just example of what are the way to represent relation. we can represent ration graph or by, like you see here, we can represent a ration. So there are represent a ration. So the first way is graphically. I have iteration, which is set of pair. So in that case, I will prepare in the as the first 5 7. So 5 I go up 7. So go down minus 7. So now I graph my ration, or we can this type of ration, for example, uh, x squared plus y squared equal, for example, it's almost like it's a circle. Okay, let me extend because it's, you see, again, this is a ration. Any form of graph is a ration. So those are examples. The second way we present ration is by ration. So like we did previously on this, those are collection R is 0, for example, or we can use the constructive collection is greater or equal than y. So this is called constructive collection of order. The last So for example, we can have x squared plus y squared equal 9, like we did. This is algebraic operation. X minus 2 is less than y, and so on. Way to represent a ratio algebraically. So, and when you present the ratio t, which is the x coordinate. So the x coordinate, example, from here to here, domain, because those x, y, called any point I do a projection on the x axis and on the y axis, so they have y has a y coordinate of are called domain. The y coordinate range. So of the other pairs are the domain of that relation, and the y coordinates of the other pairs are the range set of all x coordinates. So exactly what is domain. Domain coordinate and range. Of all for example, if we have this 792310, so it's 272 is already here, so and 1, and is a set of all the idea of range and domain. And in the point on the coordinates plane. So that's exactly how to graph a relation. We just need its other pair plane. For example, if I want to graph these relations, I have equal 1, 3, 3, 5, 7, and minus 3, minus 4. Go from the 5. So the point here will be 1, 5, and up 3. So this is 3, 3. We start from the origin, and from there we go minus 5, so minus 5 is on the left, so it's going to be here. So here 7, and here I have minus 3, so I go minus 3 and down minus 4. So minus 4 is, so, and this is how we graph relation. So this is, now let's talk about a function. Is a set of order pair without condition. Any but function, it has a condition. The condition is each order pair must have distinct x coordinate. Pair with same x coordinate. So that's the only condition. Order pair with the same x, that's the same y. Y is not a, so that's the condition of the function. So each order pair x coordinate. So function is a relation where has give you an example of function 5 minus 1 5 and minus 3 11 is a function. So the second relation 3. Again, we have the y here, same y, but the x coordinates are in terms to have the same y or not the same y. This is not the case. You see, the definition is clear. If the y coordinates are the most important different, and here they are different x coordinates, so this is distinct. So this means this is a function. This relation. So if I want 3 7 9 11, this other pair, and they have the same x coordinate. Coordinates are the same. Distinct order pair with same x coordinate. So in that case, so this is an example of a function. The notation of a function used in math. So for is we use x, or we use y. So there's a lot of to notate x. So this is exactly how we read f of x. That means f is the y depend on x. That means the input of f will give me this f of and y are the same. Those are the same. The output of x pair x y, we can x is the same thing. And we use this notation most of the time when we have two distinct functions. For example, if I this y defined by function which is 9x plus 5, and this expression depends on x. That's mean y define this expression. Those two are distinct expression. Obviously, those two y that are the same, that are distinct. But then they get confused on this. This is why we write like f of x equal 5x. And here we can write about the function. But in fact, it's the same thing. Now, how we can check if a given relation is, how we can check that? How we can check if they give us a relation is a function or not. Relation. So we can use the graph test, which is called the vertical line test. Relation is a function. So there is another way how to check if it's given algebraically. So graphically, we use the vertical line test. State function is relations. Other pair has distinct x. Vertical line, in the vertical is in fact just one x, but when it crosses the graph, it shows us how many y, or it has only one y coordinate. If I have that graph, then I do a line test. So I keep moving that line horizontally. How many points the line cross the graph? I look, it's only one. That means those 2 points, they have the same x coordinate, but they have the point. If I name that A, so here here this is my y. So the point here in the graph is a y1, a y2 are not the same. In fact, they are located in different positions. Still, they have the same what? X coordinate. So I can say that because function is must have distinct x coordinate. So we don't care about the y, we care about the x, not the function. It's clear. Example. Graph here. Keep moving my each x, this x for y. If I keep moving, each has unique y. Each x has unique. Each x there's no y that has. If I have a pair, distinct y, the same x. None of them. So I can say this is the vertical line test. So to is a function or so way. Graphically, using the vertical line test, we have distinct y, then the x coordinates are not the same. So let me use here x prime instead of y. So how we can use this? So I can give you an example. So suppose we have this relation 5x plus 9, for example. So if I start with f and then f of x prime, so I will have 5x plus 9. So here 9 both side. If we subtract the same, the difference stay the same. So this still x prime by 5 both side. And again, this still stay different. Which is equal to 5x plus 9 a function. Show algebraically a relation a function or not. So in terms of range that function is the relation. That means the domain is a set of all x coordinate and the range is coordinate. So it's exactly what is the domain and the of is the collection of all its x coordinate. Is the collection of all its y range of is the collection of it. There's one remark I want you to is false. We cannot have every relation is a function. In mind this remark. Every is a relation. False. Which means not every relation is function. Rational function, and I hope you got the main idea about which also is going to help me a lot.